BDP Industries is a premier filtration supplier with over 25 years of experience and hundreds of installations throughout the world. Since 1971, BDP has aggressively pursued design and manufacturing enhancements throughout our entire product lines to meet and exceed the demanding needs of our customers. We've become known as one of the most modern and complete solids dewatering suppliers in the world by building a reputation of quality, performance, and service. This product video will present the company's 3DP belt press. The model 3DP has been well received by the target municipal biosolids dewatering market, with hundreds of installations throughout the world. The slurry enters the system at the bottom of the vertical conditioning and distributor tank. The tank's upflow V configuration causes the slurry to spread evenly to the full belt width by the time it reaches the distribution trough at the top of the tank. The cross-sectional depth of the tank is designed based on the nominal flow rate for each project needed to provide a suitable upflow velocity that will maintain the slurry density and solids concentration. The distribution trough at the top of the distributor tank is U-shaped in cross-section with an overflow smooth weir on the discharge side. Inside the weir trough is a 6-blade paddle wheel constructed of rubber sheets that function like a rotary valve, controlling the rate of discharge from the distributor tank. The rotating paddle wheel sweeps slurry over the weir and onto the filter belt. The sweeping rotary action ensures continuous, uniform thickness of the slurry over the full width of the filter belt. This design eliminates uneven slurry distribution caused by stagnant areas that develop inside the feed distributor. Uneven slurry distribution results in uneven cake thickness, causing a differential in belt speed. This leads to accelerated filter cloth and roll coating wear.
The paddle wheel distribution box really seemed to give a very uniform, even feed to the gravity section of the press, which is really critical in operating any belt filter press, is to have good, smooth laminar flow across the gravity deck.
The paddle wheel distributor promotes longer belt life, lowers roll coating wear, and increases cake solids due to even pressure applied to the cake. The gravity zone has a separate filter belt drive from the pressure zone. This allows independent belt speed control for both zones. In the gravity zone, suspended solids are being deposited on the filter cloth as filtrate flows through the cloth. Therefore, cake thickness is increasing down the length of the gravity zone. The increasing thickness causes an increased resistance to filtrate flow and slows the filtration rate. Operating at an increased belt speed spreads the slurry over more belt area. This promotes a higher rate of filtration by reducing the effective cake thickness. In the subsequent pressure zone, the cake has been formed and no additional filtrate will be expelled unless squeezed out by pressure. In the pressure zones, the longer the cake is under pressure, the drier the cake. Therefore, a slower belt speed is desirable.
Our former press, which many of the conventional belt filter presses are, the gravity section and the pressure section are all one. You don't have the ability to control them independently, so whatever speed you have to set it at for either the gravity deck optimization or the pressure deck really sets your fate for the other. This, you can really control the gravity deck section, which we found seems to be the hinge pin of how well the press operates.
The advantages of the gravity system is that you can look at it, and if you have a problem with it, then it's not overhead, it doesn't fall down on you, it doesn't make a mess on you. You can look at it and you can actually see the problem before it actually, you can stop it and fix the problem before it actually occurs.
In this 3-belt design, belt speed for each zone can be optimized, resulting in a drier cake and higher capacity. Note that the belt in the gravity zone is operating at a significantly higher speed than the pressure zone belt. The unit is capable of being configured to allow operation as a thickener to thicken sludge prior to digestion during one shift and dewatering digested sludge on another shift. Here, we see the thickened sludge discharge from the independent gravity zone into the hopper that feeds the lower belt of the subsequent pressure zone. Note the position of the counterweighted discharge scraper blade and the hopper. In the thickening mode, the discharge scraper has been moved to the thickening position, so the thickened sludge will not fall into the pressure zone feed hopper. Here we see the thickened sludge being discharged from the tail pulley of the independent gravity zone into a hopper feeding a screw conveyor located underneath, bypassing the hopper of the pressure zone. The screw conveyor transports the thickened sludge from the end of the gravity zone to the rotary lobe thickened sludge pump to the digesters. During thickening mode operation, the pressure zone is idle. The belt drive and belt wash headers are turned off. The advantage to the dual mode is that one unit can both thicken and dewater, saving building size and capital equipment costs. Plows are used to enhance filter performance by displacing deposited solids from the surface of the cloth, allowing filtrate to flow through without having the added resistance of the filter cake. Typical furrowing plows create exposed filter cloth by aligning the cake into furrowed rows. The BDP plow design does not create furrows. The plow is actually submerged below the surface of the slurry. When lifted out of the slurry, the plow appears somewhat like an airplane wing. The wing floats on the surface of the filter cloth, forcing the sludge to flow over the top of the wing, exposing filter cloth on the bottom side for the full width of the belt press. The bottom of the wing has a recessed area that is supported by the leading edge of the wing. This recessed area on the bottom provides an area with no cake for filtrate to flow through the filter cloth. This is over twice the filter cloth area exposed versus a typical furrowing plow design. Performance comparisons show the Excelsior Plow design produces twice the filtrate removal compared to the typical furrowing plow design. Another feature that improves thickening in the gravity zone is the slide strips. Note how the shape of the slide support, a foil configuration, and surface tension between the fluid and support pulls fluid through the filter cloth. The plow and gravity zone design significantly improves thickening versus what competitors offer. With most wedge zone layouts, the belt paths are straight, forming a triangle configuration when viewed from the side. If the wedge entry distance between the belts is 1 inch and the operating cake thickness is 3/8 inch, the belts don't converge and place pressure on the cake until 2/3 of the overall length. Therefore, 2/3 of the zone is ineffective. As you can see from the side view of the Model 3DP, the belt path is curved by means of a curved support deck design. This forces the two belts to converge, immediately placing expressive pressure on the filter cake. As a result, the entire length of the wedge zone is effective at placing pressure on the cake. The belts are also forced to encapsulate the cake, reducing cake extrusion. Liquid is expressed from both sides of the cake. The liquid expressed from the top belt runs down into the perforated roll and avoids re-wetting the cake. A key feature of the vertical arrangement of the rolls in the pressure zone is filtrate diversion pans between all rolls that keep expressed filtrate from falling on adjacent rolls. As you can see, filtrate is diverted around the adjacent rolls and falls into the bottom collection pan. With conventional horizontal roll arrangements, diversion pans are not possible. Therefore, filtrate runs along the filter cloth between rolls where it is reabsorbed back into the cake. This happens because when the cake is not under pressure between rolls, it will typically expand like a sponge and reabsorbs any filtrate that comes in contact with it. Observe carefully the thickness of the cake, and you will see that it expands between rolls after the cloth filter leaves the roll. Another distinct advantage of BDP's vertical pressure zone design is that the cake discharge height is over 7 feet. This is high enough that the press does not need to be elevated in order to discharge onto the conveyor. The press can be installed at ground level, eliminating concrete pilings, stairs, and platforms, which significantly lowers installation costs. Filtrate reabsorption is a problem with perforated rolls because typically the filtrate accumulates inside the roll, building a hydraulic head. BDP's design eliminates this problem with a roll that traps the filtrate at the perimeter. The perforated outer shell is wrapped around an inner solid roll. Filtrate is trapped around the perimeter and does not accumulate in the bottom to run out at a single point. This significantly reduces reabsorption of the filtrate. As you can see, BDP's overall design places the gravity zone at waist level to the operator, with the unit sitting at ground level, and yet the discharge height is adequate for the conveyor to be installed underneath. This eliminates the need for extra platforms and stairs and allows better accessibility for operators and maintenance staff while significantly lowering installation costs.
I've more than tripled my output. Previously we were running 12 cubic yards compared to what we're getting now is 36 cubic yards in 8-hour run. Previously we had two meter presses and we were only able to run one of them at a time due to water restrictions.
All frame members are constructed of tubular steel. This results in a frame that is flat, with fewer ledges and corners, easier to keep clean, and much stronger resistance to twisting and bending. Notice how all BDP bearings are mounted to a machined pad that is welded to the frame. The pads are precision machined to provide proper alignment with the roll. Typical industry design is normally just drilling a hole in the channel frame, resulting in poor alignment and a weakened frame. Stand back and view the BDP frame design from the side. It's obvious that all components, bearings, rolls, cylinders, and such are all accessible. Disassembly is not required to access wear components. Slide strips in the gravity zone slide out sideways without removing the containment barrier. All pressure section bearings and rolls are completely accessible.
The open architecture really spoke to our maintenance folks. Our former presses, they used to have to stand on their head to service them. Every time a roller would be damaged or broken, it would always be the bottom one. They'd have to virtually disassemble the press to get to them. So our maintenance folks really like the open architecture.
That's just what it is. It's just open and you can work on it and it's easy access. Everything's nice because it's easy access. Maintenance free though. You don't normally have to work on it.
This design offers better access for monitoring and replacement of wear components when needed. The tracking paddles, control valve, and pivot slide of the tracking assembly are all designed to be rugged and dependable. The tracking paddle is fabricated of stainless steel and made extra wide to reduce wear to the paddle and the edge of the cloth filter as well. The tensioning assembly is rack and pinion style, but built with plenty of integrity. It is a rugged design for durability, but very easy to observe and maintain. All wetted components, like the feed distributor, filtrate pans, containment barriers, fasteners, and hydraulic tubing, are constructed of strong and durable stainless steel to provide excellent corrosion resistance and dependability over the life of the unit.
Regarding the quality and performance of the equipment, I would say that we expect it to be here for a long time, and the performance itself, without question, exceeds the equipment performance that we had.
I can honestly say that outside of replacing a belt, I think in 2 years, I don't think we've had any breakdown of the equipment since it's been installed. And our previous equipment, I don't think we could last 2 weeks without it breaking down. So again, you can say what you want, but the proof's in the pudding in the fact that we have performance data that show that it is performing outstanding.